All right, this is problem 1.4.47. We're being asked to solve, and we have a couple of radicals here. Anytime you're solving radical equations, the first thing that you need to do is make sure that you have one of the radicals isolated on one side of the equation. And we already have that. Whoops. We already have that here. So this one's isolated, so we can go ahead and proceed. And the process here is to start by squaring both sides because we want to get rid of these radicals. If we're trying to solve for x, we've got to get it out of the radical. And so to get rid of the radicals, our process would be to square both sides. Okay, so when we square a square root like this is just going to pop out as x minus 3. On this side, because this is a binomial term, we're going to actually have to FOIL it. And what I mean by a binomial term is we've got a term here minus another term. And so we can't just square each individual piece. This is actually 5x plus 1 minus 4, and then square root of 5x plus 1 minus 4 again. Okay. All right, so what we need to do now is FOIL this side. And so if we do that, the first here, square root times the square root, is going to allow that 5x plus 1 to pop out. And and then so that's the first, square root times the square root there. 5x plus 1 comes out. The outside is minus 4 times the square root of 5x plus 1, and the inside is minus 4 times the square root of 5x plus 1. The last is a positive 16. Okay. All right, now when we get to this point in this type of a problem, if there's still a radical in the problem, then what we have to do is we have to actually square again. Before we square again, though, we need to have that radical isolated on one side by itself. Okay, so I'm going to work towards that. First thing I'm going to do is collect like terms. Let's see my camera angle here. All right, so this is x minus 3 equal to, so I'm collecting the 1 with the 16, so we're going to have 5x plus 17. And then these two are like terms right here, so this is minus 8 times the square root of 5x plus 1. Okay, now I want to go ahead and move the 5x and the 17 over. So I'm going to subtract 5x and subtract the 17 from both sides. And so we're looking at negative 4x minus 20 equal to negative 8 times the radical 5x plus 1. All right, now I did say that we needed to isolate the radical to square again, but when we have a coefficient here, it's actually easier to just leave that coefficient instead of dividing it out at this point, because if you divide it out at this point, you actually introduce fractions over here, and that becomes much more difficult to deal with. So we'll go ahead and leave that coefficient here and consider this to be isolated. We can go ahead and square both sides at this point, and this is, again, a binomial term, just like this was up here, so we're going to have to FOIL it. So this is negative 4x minus 20 times negative 4x minus 20. On this side, we're squaring both the negative 8 and the radical. So negative 8 squared is 64, and the square root of 5x plus 1 squared just becomes 5x plus 1. Okay, so again, let's FOIL. This is 16x squared. We have plus 80x plus another 80x and plus 400. And then on this side, 64 times 5. I think it's 320, but I'm going to check it. Yeah, so 320x and plus 64. Okay, so let's go ahead and collect like terms on this side. We have 16x squared. This is plus 160x and plus 400. equal to the 320x plus 64. Okay, so at this point, we're actually done with the radical portion of the problem in terms of trying to get the radicals out of there. We're left with a quadratic, so we need to solve this quadratic. And solving any quadratic, we're going to want to generally set it equal to 0, and then either factor or use the quadratic formula. Okay, so I'm going to go ahead and get another piece of paper here, and we'll rewrite what we had. So this is 16x squared, 160x, 400, and on the other side 320x plus 64. Okay, all right, let's set this to 0. So I'm going to move the 320x and the 64 over. This thing is auto-correcting. I need to change that. Okay, anyways. All right, so we have 16x squared, 320 minus the 160 is 160, so minus 160x, and 400 minus the 64, and we have 336. All right, there's definitely a common factor in there, at least a 2, but let's try a 16. Yeah, they're all divisible by 16, so let's actually go ahead and divide that common factor out. It's going to make it much easier to solve this from here. Okay, so this is x squared and minus 10x, and this divides to be 21. Okay, so at this point, this is factorable, so let's go ahead and just factor it. If you couldn't figure out the factorization, you would want to use the quadratic formula. So 7 and 3 will work with both minus signs in there. Okay, and then we're going to set both of these equal to 0 and solve. So we get x equals 3 potential solution and x equals 7 potential solution. Now the reason I say those are potential solutions is we need to actually check them. When you're solving radical equations, the process of doing multiple squarings can actually introduce what we call an extraneous root into the solution set. And so we need to check and make sure that these aren't actually extraneous. So you're always going to check back in your original, and let's go ahead and check x equals 3 first. Here's our original, square root of x minus 3, and 5x plus 1, and then minus 4. Okay, so when I plug in 3, I get the square root of 3 minus 3, and over here, 5 times 3 plus 1, and minus 4. So this is 0. Square root of 0 is just 0. This is the square root of 15 plus 1 is 16, and square root of 16 is 4. So we get 4 minus 4, or in other words, 0 equals 0, so that does check there. So x equals 3 is a solution for this problem. Okay, and let's go ahead and also check x equals 7. Okay, so plugging x equals 7 into that equation, we've got the square root of 7 minus 3 and 5 times 7 plus 1 minus 4. So this is the square root of 4. This is the square root of 36. And here we have 2, whoops. Here we have 2 equals the square root of 36 is 6 minus 4. So 2 equals 2. So that one also checks. Okay, so there actually are 2 solutions for this problem, x equals 3 and x equals 7.